Today I am going to show you how to find real root of the system of equation by using Newton-Raphson method for simultaneous nonlinear equation. So here two simultaneous nonlinear equations are given. So that is f of xy is equal to 2x cube minus y square minus 1 is equal to 0, and g of xy, that is x y cube, that is xy cube minus y minus 4 is equal to 0. Now first, what is the theory behind it? Let the equation be f of xy is equal to 0, g of xy is equal to 0, where f and g are continuously differentiable function. Let x0 and y0 be the approximate solution. So let x1 is equal to x0 plus h0 and y1 is the y0 plus k0 be the better root. Then f of x0 plus h0 and y0 plus k0 is equal to 0, that we can write by Taylor series expansion like f of x0 y0 plus h0 f of x x0 y0 plus k0 f of fy of x0 y0. Similarly, g of x0 plus h0 plus y0 plus k0, we can do the Taylor series expansion like that: g of x0 y0 plus h0 gx x0 y0 plus k0 gy x0 y0. So this is the Taylor series expansion, and we got to linear equation. So we are neglecting the higher term. So now if I solve these two linear equation in the matrix form, means we can write in the matrix form like this is A, this is X, this is B. Now that is Ax is equal to B form. Okay, now that Ax is equal to B form we can solve by many ways, but here I am using the Cramer's rule. Now here A is nothing but del 0, so that is f of x x0 y0, gx of x0 y0, fy of x0 y0 and gy of x0 y0. Now here using Cramer's rule, so we are calculating a1. So a1 nothing but, so we have all this first column will change with B matrix. So f of x0 y0 and g of x0 y0, gy of x0 y0, gy of x0 y0. So a2 will be f of x x0 y0, f of x0 y0. So that my negative sign will come. So a1 and a2 I will get, means we have to find out the determinant. And after getting, so we got the determinant of a1 and a2. So a0 will be that del 1 by del 0 and k0 will be del 2 square del 2 by del 0. So now after getting h0 and k0 we can get that x improved root and x1 and y1. So this is x0 also. So now like that way we can do the n plus 1 iteration. So xn plus 1 is equal to xn plus hn, yn plus 1 is equal to nothing but yn plus kn. Now I am taking the example. So here this is the two nonlinear equation. So 2x cube minus y0 minus 1, and we know that A matrix, this is unknown x and b. So now first we have to calculate fx of x0 y0. So first, so fx is nothing but that partial derivation of f of x0 y0 by dou x. So fy similarly, so dou of x0 y0 by dou y. Similarly g and gy. So now if I do that partial differential equation, so that will give 6x square. If I do partial differential equation with respect to y, so that will give minus 2y. And gx is also nothing but dou of gxy by dou x, and gy also nothing but dou of gxy by dou y. So if I do that gx, so this second equation will get y cube. And if I do in that partial derivative of g of xy, so we'll get this equation. And this is the function f of x0 and f of the xy. Now we plug that x0 is equal to 1.2, y0 is equal to 1.7 of this equation. So I will get finally this. Now we put the numerical value. Okay, numerical value means x0 is equal to 1.2, y0 is equal to 1.7. After putting that, okay, so these are the value. After putting that, we got this is a, this is x, and this is b. Okay, so here x is a is a coefficient matrix, x is unknown, b is constant matrix. Now using Cramer's rule we can solve this problem. So now first we have to find out the determinant of this a matrix. Okay, so that is nothing but a matrix. So that is we got 97.910, and this is just replaced this first column with B matrix. So here, so we'll and find the determinant, we'll get this is the 3.389. okay, so that is nothing but we can say that we can also say that we change that B matrix and then that second column of A matrix, we'll get that. Similarly here too, so we change the second column of A matrix and put that B matrix. Okay, so this is the A matrix, this one is this, and this B matrix is here. Now after and we have to find the determinant. After doing the calculation, we got that determinant of this matrix is nothing but minus 5.99. so we got that. Now from after getting the determinant, we can easily calculate H0 and K0. so H0 is del 1 by del 0, so that is 0.0346, and K0 del 2 by del 0, so that is nothing but minus something 0.612. now after doing that, we'll get x1 this and x2, y1 this. So this is the first iteration. Now we have to take that for second iteration. So if I need that refined solution, so now x0 become x1, okay, and follow the same procedure, we will get the next iteration. So this give the that iteration 1 root as x is this, y is 1.6380. we can continue to refine the solution using above procedure. That's it. We know how to solve simultaneous nonlinear equation by Newton-Raphson method.